Have you ever wondered how the device you're using to watch this video came into existence? Let's take a step back in time, an adventurous journey that begins with the dawn of computing. Long before the age of modern computers, the earliest mechanical computing devices were born. The abacus, a simple counting tool, was used as early as 2700 BC in ancient Mesopotamia. It was a collection of rods and beads that allowed users to perform simple arithmetic operations. This humble invention marked the first step in the evolution of computers. Soon after, in the 17th century, we saw the creation of the slide rule, a device that allowed people to multiply and divide quickly and accurately. It was an essential tool for engineers and scientists for nearly 3 centuries, until it was replaced by electronic calculators in the mid-20th century. Then, in the 19th century, an English mathematician named Charles Babbage designed a machine unlike any other. Known as the father of the computer, Babbage designed the analytical engine, a revolutionary device that was capable of storing and processing information. Although it was never built during his lifetime, the concept of the analytical engine was a significant milestone. It introduced the idea of a universal machine that could be programmed to carry out any kind of calculation or data manipulation. These early inventions, the abacus, the slide rule, and Babbage's analytical engine, set the stage for the future of computing. They helped shape our understanding of what a computer could be and paved the way for the creation of more complex machines. Yet, these were just the precursors. The real breakthrough was still on the horizon, waiting to transform the world of computing. As we moved into the 20th century, the stage was set for the rise of a machine that would bring computing from the realm of theoretical to practical. But the real game changer was yet to come. A machine that would bring computing from the realm of theoretical to practical. Enter ENIAC, the first fully electronic computer. As the world was recovering from the ravages of the Second World War, a new invention sparked a revolution in 1946, the electronic numerical integrator and computer, or ENIAC as it is popularly known. Constructed at the University of Pennsylvania, ENIAC was a marvel of its time. It was not just a machine, but a giant, occupying an entire room of approximately 1,800 square feet. Imagine a single computer as large as a house. But what truly set ENIAC apart was its processing power. For the first time in history, a machine could perform calculations at lightning speed. It could crunch 5,000 additions, 350 multiplications, or 50 divisions in a single second, a feat that was simply mind-boggling at the time. Yet, the true innovation of ENIAC lay in its use of vacuum tubes. These were the building blocks of the machine, allowing it to execute commands and perform calculations. A staggering 18,000 vacuum tubes were used in the construction of ENIAC, each one contributing to its enormous computational power. The birth of ENIAC marked the dawn of a new era, the era of electronic computing. No longer were machines limited to mechanical operations. Now they could process information, solve complex problems, and even play a pivotal role in scientific research. Despite its size and the heat it generated, ENIAC was a game changer. It was used to compute artillery firing tables for the US Army during the war, and subsequently found applications in nuclear physics, aerodynamics, and weather prediction. It's hard to overstate the significance of ENIAC. It was a giant leap forward in the field of computing, setting the stage for the development of smaller, faster, and more efficient machines. Indeed, every computer, smartphone, or tablet we use today owes its existence to this groundbreaking invention. The birth of ENIAC was not just the birth of a machine, but the birth of a revolution. A revolution that would forever change the way we live, work, and interact with the world around us. This was just the beginning. The world of computing was about to embark on a rapid journey of evolution. As remarkable as ENIAC was, it had its limitations, which led to the invention of transistors and integrated circuits. So, let's dive right into the heart of the matter. You see, ENIAC was a beast of a machine, standing tall with its 18,000 vacuum tubes. But these tubes were not without their flaws. They consumed a lot of power, produced excessive heat, and were prone to failure. Hence, the need for something better, something more reliable, was imminent. Enter the transistor, the unsung hero in the evolution of computing. Born in the late 40s, the transistor was a game changer. It performed the same function as a vacuum tube, but was smaller, more reliable, and consumed less power. This was the first step in miniaturizing computer components. But the story doesn't end here. The 60s saw another major leap, the advent of integrated circuits, or as we commonly know them, microchips. Picture this: an entire electronic circuit complete with transistors, resistors, and capacitors, all shrunk down to fit on a tiny piece of silicon. This meant that computers could be made even smaller, and more importantly, more powerful. Now, remember, with great power comes even greater processing power. These advancements led to the development of microprocessors, the brain of the modern computer. The introduction of microprocessors marked a significant milestone, as it allowed for the execution of complex instructions at high speeds. It was like shifting from a horse-drawn carriage to a supercharged sports car. With the power of integrated circuits and microprocessors, computers started shrinking in size. The mammoth machines of yore were replaced by compact desktop-sized computers, opening a whole new chapter in the world of computing. It was like David standing tall against Goliath, a testament to the fact that size doesn't always matter. With these advancements, computers were no longer confined to large rooms and could now find a place in our homes. And just like that, the era of personal computers was ushered in, forever changing the way we live, work, and play. The 1970s and 80s saw the birth of the personal computer. As we journeyed from the colossal machines of the mid-20th century, we entered an era where computers began to shrink in size and grow in power. This was the time when computing started to become personal. IBM and Apple were the trailblazers in this new frontier. IBM, with its long-standing history in computing, had a vision to bring computing power to the masses. The IBM personal computer, launched in the early 80s, was a monumental step towards this vision. It was an affordable, reliable, and user-friendly machine that could be used in both business and home environments. This machine was not just a tool for computation, but a revolutionary device that transformed how we work. While IBM was making strides in the business world, another company was stirring up a revolution in a garage. Apple, co-founded by Steve Jobs and Steve Wozniak, was dreaming of a different kind of personal computer, one that was not just functional, but also aesthetically pleasing and intuitive to use. With the launch of the Apple II, and later the Macintosh, Apple redefined what a personal computer could be. It was no longer just a machine, but an extension of the user's creativity and imagination. These early personal computers were not just about crunching numbers anymore. They became tools for communication, for design, for learning, and so much more. They were no longer confined to research labs or corporate offices, but found a place in our homes, schools, and even our pockets. The advent of personal computers was a significant milestone in the history of computing. It was the point where technology ceased to be the exclusive domain of scientists and engineers and became a part of our everyday lives. It was the democratization of computing, with technology becoming accessible to everyone, regardless of their background or expertise. While personal computers brought technology to our doorsteps, the next revolution was set to bring it to our fingertips. Today we stand at the threshold of a new era in computing, quantum computing. As we leap forward into this new age, let's take a moment to grasp the concept of quantum computing, a development that promises to revolutionize the way we process information. Quantum computing is not just a more powerful version of our current computers. It's a radically new model that harnesses the complex and fascinating laws of quantum physics. Unlike classical computers, which use bits as their most basic unit of information, quantum computers use quantum bits or qubits. While a bit can only be a 0 or a 1, a qubit can be both at the same time. This is due to a strange quantum property known as superposition. Imagine a coin spinning in the air. It's not just heads or tails, but both at the same time until it lands. That's what a qubit is like. It's this ability to hold multiple states simultaneously that gives quantum computers their incredible power. Another quantum quirk at play is entanglement, a phenomenon where particles become linked and the state of one can instantly affect the other, no matter the distance. This allows quantum computers to process a vast number of possibilities all at once, potentially solving complex problems that are currently beyond our reach. Quantum computing could revolutionize fields such as cryptography, optimization, drug discovery, and even climate modeling. The benefits are immense, but the challenges are equally significant. Building and maintaining a quantum computer requires overcoming numerous technical hurdles, from maintaining qubit stability to error correction. But the race is on, and tech giants, startups, and research institutions around the globe are vying to unlock the immense potential of quantum computing. From ENIAC to quantum computing, the journey of computers has been an extraordinary one, shaping our world in ways we could never have imagined. As we stand on the brink of the quantum age, who knows what extraordinary leaps await us in the future?